Welcome to Precalculus lesson 3-4. Today's date is January 11th, 2021. Our objective today, make sure your cameras are on too, please. Quiet raise hand to read the objective. I don't know if that's Leo raising his hand or saying thank you.
Yes, it is.
It is Leo. Oh, yeah, go for it, Leo. Oh no, he muted himself.
These compositions of functions to verify if functions are inverses of each other.
There it is, yeah. So it feels weird that why are we talking about inverse functions if we're talking about composition of function? It's a way to verify. And there's a bunch of other ways too, like the horizontal line test. But here we go. So I am going to define inverse. F and G are inverses if I put one inside the other in any order, G inside of F or F inside of G, the outcome is X, which is kind of interesting, right? But it's saying, hey, if I have an input of X, these two undo each other and my outcome is again X. So if I put in 1, I get out 1. If I put in 5, I get out 5. That is an inverse function. It undoes the other function. And let's just see an example. There is a shortcut if you can think about it, especially for these linear equations to figure out if they're inverses or not. So let's first, well, see, F is 3x plus 6, and then G of X is X minus 6, and that entire thing divided by 3. So we understand these functions. I'm going to put G inside of F, and I want to see what this simplifies to. If it simplifies to X, we're in luck, then we're halfway done. We have to check the other one as well and see, are they inverse functions? All right, so let's do this. So G is going to go inside of F. So I'm going to do what? You guys did this homework on Thursday/Friday. No, Thursday/Friday was a quiz. So you did this homework on Wednesday where you just put one function inside of the other.
So
how do I do that?
Put X inside of F, is that what you said?
So I want to put this function G of X, this function G of X inside of F. How do I do that?
So where it says X, don't you put parentheses 3x plus 6?
So yeah, I am going to be using that 3x plus 6. Where did the parentheses go?
Right there, right?
Yep, so 3x, and that's our x, plus 6. And then what goes in the parentheses right here, Leo?
Wait, I'm lost. Is that this?
So I just wrote x. This x is this empty set of parentheses right here, right?
Yeah.
And then what gets plugged into these parentheses right here?
Is it x negative 6 over 3?
Exactly, yeah. This whole G gets plugged inside of this F. So I say x minus 6 all over 3. Perfect. And in Khan Academy, for that last homework problem, and even the quizzes and tests that are on Khan Academy, if you just enter this and hit enter, click, it'll give you 100% on Khan Academy. It is that easy. Although you guys on the paper test need to be responsible for simplifying this. And especially today, it's helpful to figure out, oh yeah, this does simplify to something else. So how can I simplify this? I need someone aside from Leo. I see 3 is now being multiplied by all of this. What is going to happen here? I need to try to boil this thing down, simplify it as much as possible. Any ideas? Yeah, Ellery?
You can distribute the 3 into the x minus 6 divided by 3.
Yeah, so you can say, so are you thinking like 3x minus 18?
Yeah, or actually you could do it, maybe a better way is to simplify in the parentheses first. So you could have 1/3 x minus 2. And then it's somewhat simpler to distribute the 3 into.
Yeah, that would work. And there's an even easier way. You want to see the even more shortcut way?
Yeah.
Those 3's just cancel each other out.
Yeah.
Because whenever you're multiplying by 3, you're essentially saying multiply by 3 over 1. And then 3 over 1 is in, obviously the 3's in the top, and I have a 3 in the bottom. Whenever I have the same number in the top and the bottom that are being multiplied, this is saying 3 times x minus 6, then you're allowed to just cross cancel. And then Ellery would be the final step there.
So then you have x minus 6 plus 6, which is just x.
Yep, this turns into just x, and we can therefore conclude, hey, Well, according to this, it looks like it is the f and g are inverses of each other. So it looks good. Let's check the other way, see if it works. It should work for both ways. I'm trying to think of a scenario where it works for one way and not the other. I can't think of one. But that doesn't mean it doesn't exist. I just haven't thought about it hard enough. Let's try the other way. So who can help me do that?
So would that be like, so you just do the same thing but with the 6?
Exactly. And next time if you could raise your hand, I'd appreciate it. I know Leo knows how to do this because he did the last one and I worked with him one-on-one too the other day. So we're going to do the same thing with the other way with 6. Who aside from Leo and Ellery can help me do that? Yeah, Beverly? You're still muted too, Beverly.
Sorry.
You're good.
You'd plug the 3x plus 6 into the x. So it'd be 3x plus 6 minus 6 divided by 3.
Perfect. Yeah, there it is. Thank you. All right. I need one last volunteer to simplify this all the way down. It should theoretically simplify down to x. Let's see how that works. Someone new. So I'm thinking either Emily, Caroline, Chewy, Oscar. Aurelio is not in this class. He was in consumer math and he never left. He just loves me so much. One of those 4. We're gonna cold call. I'm gonna cold call. Chewy, go for it.
Which step am I on?
Simplify this somehow.
So you multiply 3x by 6.
This is just saying minus 6. You don't. This is not multiplied by negative 6. It's just saying subtract 6. So if I have a positive 6 and I subtract the 6,
it's gonna cancel out to 0. Would it just be negative 3x?
it's just a normal 3x now. Again, that minus sign is not being multiplied. It's just being subtracted. So 6 minus 6, they're gone. They canceled out, as you said.
So it'd
You're left with
3 so it'd be 1
over 3. And yeah, 3 and 3 reduces to 1, and you're left with just
1x.
1x, exactly, or just x. Yeah, nice. Thank you, Chewy. So we've checked both ways, putting g inside of f, f inside of g, and both of them give us x. Therefore, we can conclude our f and g inverses. We can come down here and the big all caps. Yes, they are indeed. I don't know how to spell yes, apparently. Yes, they are indeed inverses of each other. And Sam, just joining us, the definition of an inverse is if you put one function inside the other and you get x, or if you do it in reverse, f inside of g and you get x. If you get x, that is an inverse function. And I'll zoom out for the notes at the very end too, Sam. Let's try another one. And this is the same type of homework problems you're going to be seeing. They're going to give you 2 functions, and you're going to plug one inside the other, see if it gets you x, then you're done, over and over again. Example number 2. And by the way, let me hint at the shortcut before I move on to example number 2. Think of the shortcut if I was trying to isolate x. If you just saw 3x plus 6 and some other variable over here, if you had to isolate 3x plus 6, what would you do to both sides? And hopefully, as I say that, you're like, oh yeah, you subtract 6 and then you divide by 3 because you have to get rid of that 6 first, so you minus 6 on both sides. And then after you do that, the very last step would be divide by 3. Think about what I just said in words. Subtract 6, then divide by 3. This is subtracting 6 and then dividing by 3. And then you can do the vice versa way of doing it. So how would you undo things that are happening in x? That's what it literally means to be an inverse function. So there is a way to do these in your head without actually plugging them in. But let's plug them in. For example, 2. There are your 2 functions, our g of x functions. I changed the letters randomly, g and h instead of f and g. So g of x is 12 minus 3 over x, and h is negative 3 times the quantity of x minus 12. I mean, at first glance, yeah, it probably is, right? I'm somehow getting rid of this negative 3. I'm somehow getting rid of that 12. The numbers seem to be right. It's not like randomly a 15 or something over here. So we have to verify that. So someone that hasn't spoken yet today, and it's going to be Oscar, Emily, Sam, or Caroline. How do I plug h into g? How do I do that composite function? Cold call, eh? All right, Caroline, you're up.
Would it just be 12 minus 3 over negative 3 and x minus 12?
Yep. Perfect. So we rewrote g, the most outside function, and then in the place of the x for our g, that x was our h. Okay, so we're getting better and better about doing these composite functions. Okay, I need yet another volunteer. Simplify this for us. Use this trick. Well, this negative can really be here. Here's the one of the tricks that I'll just give it to you. I'm really going to apply this negative to the numerator here. So I'm really going to say plus this negative 3. You're allowed to do that. It's the same thing as saying, how do you do 3? It's an inverse rule. 3 plus a negative 2. Well, that's the same thing as 3 minus 2. So I'm allowed to do this. And this trick that I showed Ellery last time, ooh, I have a negative 3 in the top, a negative 3 in the bottom. That negative 3 is being multiplied by something. That means I can do something else to that. Everyone remember that trick? No. Emily, do you remember that trick? What would I do with that negative 3 in the numerator and negative 3 in the denominator? It's very similar to like if I had like 2 over 2 or 2x over 2x over 2. If you have the same number and same number in this scenario, well, then they just cancel out. If you see the same number at top and bottom, just cross them out and you're left here with just x. How does that apply to this example over here, Emily?
Cross out both of the 3s?
Yeah, and we can cross out the negative part as well. Yeah, both negative. So cross them out, shoink, shoink. And now, Emily, we're left with 12 plus, there's nothing on the top. So when I divide negative 3 by negative 3, I'm just left with 1. So you can't just put 0 there. 1 over x minus 12. And how am I going to solve that? How am I going to reduce that? So there is a step to try to reduce this as much as possible. I don't know if you need to though, because at this point we're kind of saying there's not a really nice way to get this to x. I mean, that's the goal, right? We want to say, hey, this is somehow x. It's not though. It's very clear by this step to say, hey, we're not. I think, and I hope I'm not leading people astray. Just enter this into Khan Academy and say, yeah, it's not x. But I'm going to go ahead and show you how would you actually add these two together if you wanted to. Well, you need like denominators. So you need to multiply this 12 over here. Let me give myself some room. Move you over. We need to multiply that 12 by x minus 12 over x minus 12. And then you'd have like denominators. And then you could actually add the 1. And this would eventually turn into, well, 12 times x is 12x. 12 times negative 12 is negative 144. But I also get to add 1, so negative 143. All divided by that common denominator, which are now the same, x minus 12. And this is what it eventually turns into, but I don't think you need to do that for Khan Academy. Something that you should know how to do from Algebra 2. I think this is an Algebra 2 skill. But again, I don't think it's necessary. What about the test, Mr. Sindel? Nah, just go ahead and leave it like this, 12 plus 1 over x minus 12. As long as you've shown me, hey, there's not really a good way to get to x, I'm fine with that. That's the main point of this lesson. Okay, let's do the other side. Maybe the other side will work, I don't know. Probably not, since the first side didn't. I need to plug g of x into h of x. That's the composite function, h of g of x. Who can help me? All right, Oscar, you're up.
I don't know.
Okay, well, look at the way that we did this one up here. So G was on the outside. So we basically rewrote G, 12 minus 3 over X. But in the place of X, we plugged in the H. So basically rewrite that outer function again.
Okay, so is it -3 parentheses X minus 12?
Yep, and then I'm going to put that for our X. That's our X minus 12. And then in the place of this X, what do we put?
You put 12 -3 over X.
There it is. Yep. That is the composite function h of g of x. Nice. All right. And maybe Sam is having internet issues because she popped out again. I think everyone is now spoken. So just kind of a free for all. What would be the next step here to try to simplify? Beverly?
Would you distribute the -3?
You could. There's actually an easier way because there's what we can do right now is we can drop these parentheses, and then it might be a little bit more obvious. How could you simplify that inside part? By just combining like terms.
-12.
Exactly, yeah. So those cancel each other out. 12 minus 12 is 0. So now we're left with -3 on the outside of the parentheses. And then on the inside parentheses, just that -3 over x. And Beverly, I think you can do that for us as well. What does that turn into?
9 over 3x.
No, just 9 over x. Because when you distribute the 3, you're really distributing 3 over 1.
Okay, so just x.
Yeah, there it is, 9 over x. And I think we can all agree 9 over x is not x. So we can come down here and say, are G and H inverses? No, no, they are not, because that's not x. So while I'm fairly certain that you only have to do one of these and not both of them, on Khan Academy for this homework assignment, at least, you need to do both of them. Cool. I have one more example and then we're done. I think just one. Example 3, there's no example 4, right? Yeah, it's just kind of a bigger example because it has cube roots and powers of 3. But let me check for understanding for a sec. On example 1 and 2, fist of 5, how are we feeling about those? You can 4s. Everyone is at a 4. What do you got, Oscar? 4 as well. Okay, literally everyone is at a 4. Very cool. Let me zoom into example number 3 then. So there it is. We have a cube root of 5x plus 1 over 4, and our other function is 4x cubed minus 1 over 5. And again, at first glance, they look to kind of have the same numbers. And I know that a cube root cancels out a cube. So I'll have that rule written on the side just in case we forgot. If I have like x cubed and I take the cube root of that, that turns into just x. They are inverses of each other. So, and they all seem to have similar numbers, +1, -1, multiply by 5, divide by 5, divide by 4, multiply by 4. They all seem to be inverse operations. So at first glance, I would say, yeah, it kind of looks like an inverse function, but we have to check. So can anyone give me the composite function f of h of x? And everyone's already participated, so this is just kind of free game. Who wants to do it? Okay, well, I want to give you time to do the homework. I guess I'll do this one. I feel bad. Like this is a chance for you guys to put yourselves out there, to show what you know. But no one wants to do it. Okay, so f is the most outside function, so I'm going to rewrite this f function. But in the place of x, I'm going to leave an open parentheses. So I'm rewriting f. This is going to be, whoa, cube root of this fraction thing. This fraction thing has a 5. There's my x. I told you I would leave a giant. I kind of need to make this bigger, don't I? Let's make it like this. 5, and then my parentheses looks like that. That's my 5x. I just rewrote 5x. I need to write the plus 1, and then that's all divided by 4. Okay, so far so good. I've rewritten f, but in the place of x, I left an empty parentheses. What goes in that empty set parentheses? Well, h goes in there. H is inside of f, so I'm going to write this 4x cubed minus 1 all over 5. What happened to my 1? I don't know. There it is. Okay, and is there anyone that wants to show me a few steps? There's like 3 or 4 steps for this one to try to simplify. And to give you guys a hint, focus in right on this area right here. How could you simplify something in that orange rectangle? Yeah, Beverly?
Would it be the 3s? Can you cancel out the 3s?
This 3 and this 3?
Yeah.
Not quite. So I was just focusing more inside the rectangle because I can't take the cube root of all of this yet. The cube root is applying to literally every piece of this. And it's really hard to take the cube root when it's not strictly just the cube root of something cubed. But what about the 5s? Can I do something with the 5s?
You can cancel those out.
Yeah, so let's cancel those out. 5 is gone, 5 is gone, and our new function looks like this. You see how that giant cube root, why is my computer lagging so bad? It's annoying. Cube root of, now I have 4x cubed minus 1 plus 1 all over 4. All right, another step. Let's do rapid fire here. Quiet your hand. Ellery, go for it.
You can add minus 1 plus 1, and then that leaves you with 4x to the 3rd over 4, and then you can cancel out the 4s. So then you have root 3 of x cubed, and then that cancels out and leaves you with x.
There it is. Thank you. And it's looking like the answer is going to be yes down here to our f and h inverses. Let's check the other way as well. I'm going to run through this fast so that I give you guys time for homework. Again, how do I plug f into h? We'll rewrite h first. So h is this function and give a big set of parentheses for the x. I have 4, there's my x. I'm going to have that big of an x. That x needs to be cubed. I'm going to pause because I want people to really understand what's going on here. This is 4x cubed minus 1, and then all of that divided by 5. And inside of this x, f is on the inside, so I'm going to rewrite this cube root function. This goes right here. So cube root of this fraction, 5x plus 1 over 4. So I'll pause and make sure everyone has this written down. So in the last case, Beverly wanted to cancel out the cube root and cube, but you couldn't do that because not everything here was to the power of 3. But in this case, you can now because everything right here is being cube rooted, and that's also to the power of 3. So the first thing that we can do in this step is we can cross off the cube root and the power of 3 to make our new function. Our new function is just this 4 times the quantity of 5x plus 1 over 4 minus 1 all over 5. The cube root and cube are gone. And then from here, it's even easier. 4s and 4s, you can see I'm multiplying by 4 over 1. So the 4s are going to cancel out, cross cancel. You can see, oh yeah, then I'm going to have the new equation down here. 5x plus 1 minus 1 all over 5. And once you hit this point, I'm guessing a lot of people have the mental math capacity to say, oh yeah, -1 plus 1, those are gone. And 5x divided by 5, that immediately is just x. The 5s and 5s cancel each other out, shwink, shwink. And we get x. And because both of these turn into x, you can answer yes. F and H are indeed inverses.